Hello, dear students. How are you? Make sure the screen is visible to you. If the screen is visible to everybody, say yes in the chat box. Okay. Only Bhagat has respond. Screen is visible to all. Okay. Everyone, please respond. Nagashri is here. Priyanka, Ching, and Jane Viroin, and Bhagat. Okay. Good evening to all of you who are present here. My voice is coming to you perfectly. Am I audible to you? Okay. Okay. Very good. So it's a long time that we have been introduce ourselves, है ना? Due to some issues, I was not able to taking the class. So the classes was merged before, and I hope that you have enjoyed the previous sessions with Akshmala ma'am. Now from here onwards, we will be continuing the classes. Okay. So the topic that we have chosen for today is current electricity. Okay. We will be running this current electricity throughout this week. Okay. So each and every doubt is welcome, and your response matters a lot. Okay. Now make sure that everyone has to respond in the chat box. Based on your responses, your performance will be analyzed. So make sure that everyone responds. Okay. Any kind of doubt at any point of time will be answered. Okay. So there are 32 students here. At least 30 plus responses I want in the chat box. So are we ready to go? Say yes in the chat box, or you can do any emojis also. Okay. Nyang Hoi, Madhukar, very good. Nisarga is also saying visible, sir, and we are ready to go. RJ Krishna, okay, okay. So the students that is not being responding, I consider that they are listening to me but not able to respond due to some technical errors. So we will be continuing the class right now. Okay. So as you can see here, the topic that we have chosen for today's classes is what? Current electricity. Okay. Till now, whatever the chapters we have covered, whether it is electrostats or capacitance, in both of the chapters, most basically the charge that we have kept in rest. Okay, so we haven't talked about what will happen when the charge kept in motion. Okay, charge attain a motion. So in current electricity, we will give you a very basic idea about how the charge behaves when it comes into the state of motion. Okay, so this chapter is purely dedicated to how charges Guys, sorry for the interruption because of the network issue. Now the screen is visible to you. The topic that we are going to cover today is uh, electric current basically. First of all, we will be having an idea about the electric current, and then we will proceed about the Ohm's law and dependency of the resistance on various factors. Okay. Am I audible to you? And the screen is visible to all of you? Give me a yes and no in the chat box. Okay. At any point of time, if voice is not clear to you, please message in the chat box. Okay. So the topic that we are going to cover today is first of all the electric current. We'll see what electric current is and the types of electric current also. Types of. Then we will have a brief idea about Ohm's law. That is very important basically. And because of the Ohm's law, we define a new term that is resistance. Guys, give me the 2 minutes, okay? I understand that you can't see the slides. Just give me 2 minutes. Now the screen is visible to you. Everyone, if the screen visible to you, say yes. Everyone has to respond. Okay. ठीक है, then we will start. So firstly we introduce what is current. Okay. Look. So whenever some charge flow from one place to another place, we see that the charge is kept in motion. We define a term specifically that charge is being in motion. Okay. So something different will happen if charge is in motion. So the amount of, when you say the amount of charge, net charge, flowing through an area of cross section per unit time is defined as the electric current. Now this area of cross section is important. Area of cross section का मतलब है कि whatever the area you are having, in this case we are having a pipe. When you cut this pipe in this manner, okay, perpendicular to the axis of this pipe, then that particular area is termed as area of cross section. So whatever is charge is being flown from here to here, okay, through this area of cross section, that particular charge per unit time is termed as current. ठीक है, इसे ही हम क्या बोलते हैं, इलेक्ट्रिक करंट. Suppose, for example, there are two discs which is attached to the end of this pipe. One disc is positively charged, one disc is negatively charged. So what will happen in this case? The negative charge will flow from, suppose this is right, this is left. So negative charge flow from right to left and positive charge flow from left to right. There is no confusion in this because positive want to capture this negative and negative wants to capture this positive. Okay. This process takes some time, but a very short time. So the charges is motion through this area of cross section, that the charges will cross each other. ठीक है, इस area of cross section से these charges will cross. ठीक है, so according to the definition, the amount of net charge, so we can say the net charge here is q plus minus q minus. ठीक है, whichever is greater, the net charge will take that particular value. If positive charge is greater, then positive charge will be exceeding. If negative charge is greater, negative charge will be exceeding. ठीक है, so that is the meaning of this net charge. ठीक है, any doubt? Okay, there might be some internet issue with them. ठीक है, so here we can say the net charge that we are having is q plus and minus q minus. ठीक है, but we know that when these charges travel to this right side and this negative charge travel to the left side, at the point of equilibrium there will be no flow of charge. So this particular development of current is not steady. It's not steady. Whatever the current is being developed due to this flow of charge is not steady. So to make this current steady, what we will do, we will attach a battery or any electrical appliances. ठीक है, to make the current continuous and steady. That you can see in this picture. You can see we have connected a battery to continuously lighten up this bulb. Okay. To continuously lighten up this bulb, we need to provide a constant source of electricity, and that will be fulfilled by this battery in this time. Okay. Got it? Now, whatever the current is, there are two types of current: the average current, the instantaneous current. You can relate it with the very common thing that, like in the previous 11th class, you have studied about the speed. Okay. Speed is what? The change of distance per unit time. Distance per unit time. Or you can say the rate of change of distance. Here you can say the rate of change of net charge with respect to time through a particular cross section. So at the same time, when we defined speed as two types, average speed and average instantaneous speed, in the same way we can define current also. The type of current is also average current and instantaneous current. Okay. Chalo. Let's just talk about the average current and instantaneous current. Okay. And after that, we will be solving this question. So if I talk about the average current, average value of current, it is nothing but delta Q by delta T, which means the total charge, total charge flow divided by total time. ठीक है? Total time. ठीक है? So the time here that will be calculating, that we are using to calculate average current, is pretty good, not very small. But what if we want to calculate the value of average current at a point of time, at a particular instant? So for that, we need to define the instantaneous current. Instantaneous current. And that we can define from the average current itself. If limit delta t tends to 0, delta q by delta t is equals to, gives by dq by dt. So this particular value of current will be defined as instantaneous current when you will be asked current at a particular moment or at a particular instance. Okay. But when you will be asked for an average value of current, then you have to apply this formula. But when you have to ask about this instantaneous current, if examiner asks you to find the instantaneous current, then you have to apply this. Okay. At that particular moment. Now, the question arises here is, as you can see on the screen, charge through a cross section is given by q is equals to 2t square plus 5t. So here you can say that the charge is dependent on time, which is 2t square plus 5t. Okay. So definitely as the time changes, the value of charge will be change. ठीक है? जैसे जैसे चार्ज की वैल्यू चेंज होगी, सॉरी टाइम की वैल्यू चेंज होगी, वैसे वैसे current will sorry this charge flow will be changed. ठीक है? Because charge here is dependent on what? Charge is dependent on the time itself. ठीक है? Now if you can see here, the expression that is given by q is equals to 2t square plus 5t. Now in this question, what is being asked? Find the current at t is equals to 2 seconds and average current at t is equals to 3 seconds. Okay? Which means that firstly you have to find out the instantaneous current, because it is asking for a particular instant. At t is equals to 2 it is asking. Okay? Very good, Srujana. We will check what the answer is correct or not. Okay? Everyone has to solve this. So to find out the current at a particular instant, t is equals to 2, we need to define the instantaneous current. And for that, dq by dt is well known. Now what we have to do, we just have to differentiate this expression. dq by dt is equals to 4t plus 5. Okay. Now at t is equals to 2, we have to find out Now you can put the value here. 4 into 2 plus 5, which is equals to what? 13 ampere. Okay. The SI unit of the current is ampere. So it is 13 ampere. Very good, all of you that has answered. Tarun, Jai Krishna, Madhukar, very good. Okay, Srujana has already answered. Now, the next question here is this particular question we have completed. है ना? The next question here is what? Next question is the average current at t is equals to 3 seconds. Okay. So whenever it asks for the average current, you have to take, if it is saying 3 seconds, you have to take a time slab of 0 to 3 seconds. Okay. If it is not mentioned. But if it is saying that it is asking for t is equals to 1 to t is equals to 3 seconds, then you have to put accordingly. But if only 3 second, 4 second, 5 second is mentioned, then you have to take time from t is equals to 0. Okay. So to calculate the average current here, what we will do? Total charge flow. So in this case, you get up this expression of 2t square plus 5t, which is given to you. You take up this expression, calculate the value of charge that is being flown from 0 to 3 seconds. Okay. So firstly, put t is equal at 0, the charge flow will be 0. You can see here. But at t is equals to 3 seconds, put t is equals to 3. So 2 into 9, 3 square is 9, 5 into 3. Okay. So 2 9 ja 18, 18 plus 15. Okay. So it will become 33, if I'm not wrong. 33 coulomb. Okay. 33 what? 33 coulomb. Now, what will be the value of average current? So average current will become total charge delta Q divided by total time. So total charge we have calculated as 33. Total time is taken as 3 seconds. So divided by 3. So answer would be 11 ampere. Look how simple is this. है ना? It's an easy peasy one. Very good. Sneha, Vedant, Madhukar again. Very good to all of you. Those who don't understand this question, didn't get the idea what we have did, can make a response in the chat box that we haven't understood this. Okay. I'll re-explain this again. So everyone, if you understand this question, please answer yes in the chat box. Otherwise, we will move ahead. Okay. Okay. So all of you have understood, huh? All of you have answered. Okay. Very good. Very good. So based on this, if I give you one question, you will solve it for me, na? Will you solve it for me? So I am giving you a question here. Try to solve it within a minute. The expression that is given to you is, again, Q is equals to 2t square plus 5t plus 2. Now, you have to find out what is the average current, delta Q by delta T, at T is equals to 0 to T2 is equals to 2. Now, tell me what is the answer. I'm giving you 1 minute to solve this question to all of you. Solve karo. Put T1 is equals to 0, then you will get a value. Then put T is equals to 2, that you have a different value of charge. Then find delta Q and divide it by delta T. Okay, Vedant, do not rush up, okay? Take your time to solve it. only average current you have to find for 2 seconds. ठीक है. ठीक है. So I'll solve it once again for you. देखो. So T1 is equals to 0 पर this time, if I just have a value here, when you put T1 is equals to 0, at that time you are not having zero charge. At that particular instant, you are having some value of charge. You can see here. है ना? So as you can see, at T is equals to 0, Q1 is what? Okay, everybody is answering as 10 or 9. Let me see. So Q1 is 2 ampere, 2 coulomb. Okay, when T is equals to 0, only this 2 will remain. But when you put T2 is equals to 2, at that time Q2 is what? 2 into T square. T square means 2 ka square is 4. So 2 4 ja 8 plus 10 plus 2. So it is 20. When you find this delta Q, it is Q2 minus Q1, which is 20 minus 2. Gives you what? 18 coulomb. So to find out the average current, it will be delta Q by delta T. Delta Q is what? 18 coulomb divided by delta T is what? Delta T is 2 seconds only. So those who have answered 9 ampere is absolutely correct. Others, they have to check their answer or calculation once again. Okay. So whenever the question is provided to you, try to think about it and then solve. Okay. Do not go in hurry and that we have to answer very first. Okay. ठीक है तरुण. Everyone, Priyanka, Tarun, Pallavi, Madhukar. Pallavi, you have to check your answer once again. Huh? Madhukar, Nagashri. The correct answer is 9. ठीक है. क्लियर है सभी को. चलो नेक्स्ट सिचुएशन पे चलते हैं. Next question given to you is this. It's a very good question. A non-conducting ring of radius capital R is rotated at a constant angular speed of omega. This is not W, it's omega. Okay, omega. The ring has a distributed charge Q over it. Find the equivalent current. So ये हमारे पास जो ring है, this ring has a charge Q. Let's say this is a positive charge. So this ring has a positive charge all around it. And because this is a non-conducting, so all charge will be static at a one point. The charge will not move itself. ठीक है ना? And that we have said in the electrostatics. So for a non-conducting body, charge will not move from here to there. ठीक है? So whatever the positive charge present at this spot, it will remains present at this spot only. Got it? Now, let's just see how can we define the electric current. Electric current is defined by the charge crossing an area per unit time. ठीक है, per unit time. Now in this situation, in this question, what you will see, this ring is rotated only. ठीक है, this ring is rotated with angular speed omega. So the charge is not crossing any cross section, if you can see here. So what we will do, we will consider a cross section here at this point of time. Now, if the ring is rotated, so this charge will move here, this charge will move here. So ultimately, what will happening? The charge is flowing through this cross section. ठीक है? The charge is crossing this particular cross section. So that is why we can say there is a development of current in this disk. ठीक है ना? Let me go it once again. देखो, the ring is rotated itself. Okay, so how can we say that charge is crossing an area? So we will assume a very little area, very small area here at the periphery of this ring. Now when the ring rotate, the charge will move like this and cross this cross section. So at that particular, it is satisfying the condition that charge crossing an area per unit time. So at that situation, we can say that there is a development of current here. Okay. Now how to calculate this? So we can say that, अब देखो, whatever the charge is present on the ring, the total charge present on the ring is what? Total charge, total charge on the ring is capital Q. देखो, if this ring has a total charge capital Q and we have make a spot here, okay, suppose there are 5 men are standing on this ring. There are 5 men standing on this ring. So when we can say that these 5 men have crossed this, whenever the ring has made a particular rotation, when the ring made a full rotation, at that point of time we can say that all the 5 men has crossed this cross section. So whenever this ring rotates in this, whatever the manner is, anti-clockwise or clockwise, when they cross this cross section na, completely at one revolution, when we say the total charge is being transferred through this cross section. ठीक है? Got it? So to flow the total charge, to cross the total charge capital Q, we need to make a revolution, complete revolution of the ring. ठीक है? So let's say the time taken by the revolution is capital T, which is given by what? 2 pi by omega. When the angular speed is given to you, the time period is given by 2 pi by omega. Now it's very simple. The current you can say is Q by capital T. So we can say it is Q upon, put the value of T, it is 2 pi by omega. So we can say it is Q omega over 2 pi. Okay. Now, if the radius is given, so we can convert this omega into linear velocity. So we can say that omega is nothing but V is equals to R omega. So omega is equals to V upon capital R. So we can say if you put the value, it will become QV over 2 pi capital R. Okay. Clear है सभी को? Everyone, any kind of doubt in this? Very good, Sams. Sams has already answered this question. Very good. Any kind of doubt, guys, in this in this? Say yes and no if you have any kind of doubt in this. Tarun, Sneha, everybody is present here. Any kind of doubt in this question? Priyanka, okay. So I'm considering that you totally understand this. What about you, Bhagat, Bhuvan, Ching, Priyadarshini, JNV, Chura Chandrapur, G Kaushik, JNV Bidar, JNV Kokrajar, Karthik, Lava Kumar, Madhukar, Nagashri. Everyone has to respond. ठीक है? Okay. ठीक है, ठीक है, ठीक है, I got it. चलो नेक्स्ट मूव करते हैं. The next topic of today's class is Ohm's law. So Ohm's law के बारे में you have a basic idea till your 10th class. ठीक है, in your 10th classes or your high school. Okay, Ching, thank you. So in your 10th class you have a brief discussion about the Ohm's law, that what a Ohm's law is. Now we will be analyzing it in the same manner. ठीक है. So first of all we define Ohm's law. Okay, why do we need Ohm's law? That is also a point of concern. So we will totally understand this one by one. Okay. Now, first of all, the definition of Ohm law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all the physical condition and temperatures remain constant. Okay. So we have seen in the previous slides that if we having a conductor, we are having a conducting body. There are free electrons present in that body. Okay. So whenever an electric field is applied to it, okay, so what will happen? This electric field will try to push this electron away from the field. Okay. So this electron will be accelerated, or they will move opposite to the electric field. And if we connect it through a battery, because of this battery of potential V, this electric field is being developed. Because in the previous chapter, I hope that you have remembered this expression that dV is equals to minus E dot dr. Okay. So whenever the potential difference is applied, there is a development of electric field. So here we can say that there is a length of the conductor is, let's say, L. So potential and electric field and the length of conductor we can relate like this. V is equals to E into L. Okay. So because of this electric field, this electron will push into the opposite direction of the electric field. Okay. And due to this flow of charge, a flow of negative charge through a cross section, there is a development of current. Okay. And the direction of current is always opposite to the what? Opposite to the flow of electron. So if the electron is flowing left to right, the current will be right to left always. Okay. So Ohm's law says that the voltage across a conductor is directly proportional to the current flowing through it. So whatever the voltage you have applied is directly proportional to the current that is being developed in that conductor. We can say that V is directly proportional to I. To remove this proportionality sign, we introduce a constant here, which is termed as resistance. Okay. This R stands for what? Resistance. So this is a very important relation that you must remember, that V is equals to I into R. But do not think that this R would depends on the voltage and current. No, never. Okay. The dependency of resistance is pretty different, same as the capacitance. If you see the formula, Q is equals to CV. Okay. In this C is what? Capacitance, but this capacitance does not depend on the charge and the voltage itself. It depends on the geometrical condition of the plates of the capacitor, whether the plates are circular or rectangular, what is the distance between the plates, the separation between the plates, and the material that is being filled between the space of the plates. So it is totally independent of the charge and the voltage itself. In similar way, this resistance is also independent of the voltage and current flowing through that conductor. Okay. Now there are various relations that you can obtain through this equation. Okay, you can find out the value of current, that is V by R. You can define the value of R, which is R will become what? V upon I. So you do not have to remember all three values. You just remember this magical triangle. So in which you can place voltage at the upper side, I at the lower hand side, and R is the right hand lower hand side. Okay. So this triangle you can make in your mind, VIR. Now you can see here it is V by, there is a symbol of division. So V by I defines what? R. So if you take these two, it will gives you this one. Okay. Let me show you here this one. Let's
Hi, my name is Tina. Hi, hi guys. Study very hard, guys. Star. Guys, can we leave? Guys, can we leave?
Hello everyone. Hello, good evening. Okay, so actually some problem happened with Arun. That is why he got disconnected. So some emergency happened. I'm really sorry. He just told me to inform you guys. So here I just came to end the class. Okay. So everyone take care of yourself. Stay good. Keep reading. Keep enjoying. And thank you for your patience. Okay. Bye bye. Take care.